Hi everyone. Today I would like to present to you our work on supporting renewable energy communities through an interactive coordination system. I'm Panagiotidou. I'm an assistant professor at King's College London at the UK, and this paper is an outcome of a great interdisciplinary collaboration with Enrico Costanza, Michael Fell, Farhan Samanani, Kyrill Potapov, Sonia and Hannah Knox. So for years, HCI has focused on visualizations for behavior change. For instance, in-house smart displays might be familiar to some as ways to visualize energy consumption live to a household. However, critical research in HCI has shown that climate change is a larger issue that needs addressing on a wider scale than the individual, so for instance at collective and policy levels. So one collective approach to tackle challenges like decarbonization, grid management, and energy affordability are energy communities. Energy communities are citizen-driven actions that try to support the local use of often renewable power that is generated among them. So energy communities can take diverse forms, from neighbors sharing a set of solar panels, to groups coordinating the switching of energy suppliers, to peer-to-peer energy trading groups. In all their forms, either way, it is estimated that they may produce up to half of the EU's renewable energy by 2050. So such communities, you can understand, are considered key actors for achieving a clean energy transition. So in our research, we wanted to understand how can energy communities coordinate to make the most out of their renewable energy. So we used a scenario where a group of neighbors shared a solar panel. How could they make the most out of the energy it generates? And let me explain a little bit more what I mean. So the switch to renewable sources of energy requires a shift from demand-based patterns of usage to supply-based patterns, where we need to adapt to the availability of the renewable resource. Let me explain with this graph. This is what the typical day of a household with a solar panel might look like. The solar generation is shown in yellow, and you can see that it's during daytime and then it peaks during during midday, during noon. And this is a quite simplified, it's very rarely such a smooth curve, but you can understand that this is more or less what such a curve might look like. Now, the green line shows what the energy usage of that household will be, which very often the highest it comes is usually early in the evening, where people are preparing, they're cooking for dinner, their dishwashers, their laundries, and so on and so forth. So demand shifting would be moving the activities from the early evening, in this case, for instance, during the middle of the day. And demand shifting has been studied quite a lot for individual households, for instance, through eco-feedback visualizations that show live consumption. But in energy communities, the shifting may need to be coordinated amongst households, not only within one household, but be amongst all of them, as the energy usage might increase during the similar time period. So if everybody moves their activities during midday, it would still go over the solar curve. So in our previous work, we organized a series of workshops to understand how would people want to coordinate and communicate in such situations. And these workshops were very insightful in terms of, we learned, for instance, about the level of privacy, that people would like cooperation rather than competition, and that they were expecting some kind of communication and interactions to happen with their neighbors. And based on these insights, we designed a common visualization that communities can use to coordinate their solar generation and their solar consumption among them. Specifically, we designed and developed SolarClub, an interactive tool that supports energy communities in demand shifting and coordination. SolarClub is based on the principle that in order to be able to efficiently and collectively use the limited resource of a shared PV installation, households need to be able to see a forecast of when the renewable energy is expected to be available, and also see the intention to use energy at specific moments in time. So it thus provides a visualization of the expected PV generation. Here you can see that in orange. And it also allows for households to book real-time slots for their energy consumption activities, which these bookings are shared and shown to the other members. So here you can see some bookings with the boxes, the black boxes that are around the solar generation. So we have some key design decisions here. So first, learning from our previous workshops, we took a privacy-preserving approach. So we removed any identifiable information from the bookings, as well as the historical energy generation of visualizations, so that people cannot identify who is booking or who is consuming the most, for instance. We also separated the booking types based on their level of flexibility of that person. So when somebody would make a booking, they could indicate if they're flexible to change it, for instance, if somebody else wanted that time slot instead. And that is visualized in the black boxes through this type of pattern on top of it. Finally, we also offered some summary overview of the consumption data so the group of neighbors can freely browse their collective performance, but as well as have some statistics or some metrics of how they are doing as a group. So here you can see, for instance, that it compares how much of the solar panel energy they have used this week versus the week before. And they were kind of informed by that through the front page of the SolarClub. Another key design decision we had was that we wanted the bookings to be accurate in terms of kilowatt hour consumption. Insofar that when somebody makes a booking of their laundry, that represents their real laundry and how long it would actually take. So to do that, we created a separate annotation interface for the neighbors to use for a week. So this is individually for each house, and they could use this interface to see their live consumption and then identify how much their different activities consumed. Here you can see, for instance, how much a dishwasher or a laundry would consume and how that would look in that annotation interface. So we tested SolarClub with 4 groups of actual neighbors within the UK. Each group had 3 to 4 households, so there was a total of 15 households in our deployments. And because there was potentially more than one individual interviewed in each household, we talked to approximately 19 individuals. Our study design went as such. First, we installed the sensors, which would actually sense the live electricity consumption of the household. Then we gave them the annotation interface, which people used to track their activities for approximately 1 week. We then introduced them to the SolarClub system and introduced them to each other when possible. And then finally, they went through a process of coordination for what we call coordination and used SolarClub for 3 weeks. In that phase, they were told that they would try to use as much of the solar energy as possible. But we didn't tell them more details about how they should go about doing that. And finally, we uninstalled the sensors and did an exit interview. As I mentioned, we had 4 groups of neighbors where we deployed this intervention. And what we did is, because we had the first week where people were only annotating and were not told to coordinate, we used that as a baseline to compare to what extent did their behavior kind of shift from the first week when they were doing annotation to the next 3 weeks where they were coordinating. So for the annotation, we tracked by default how much activities they were doing during solar hours and their total consumption. And then we tracked the same information during the coordination phase. So we saw how much solar consumption they were doing during the coordination, which we would expect it to be more because we're asking them to shift their activities towards solar time. And then also see how much was the total consumption to make sure, for instance, that they're not just increasing their consumption. And we had interesting data because here you see like the shift from solar to total ratio was actually, in the majority of times, positive. That means that people were actually managing to shift quite a lot from their original activities to more times of solar. There were only 2 cases, like household 5 and household 14, where that was not the case. And household 5 is actually especially interesting because that participant was mentioning how they generally do not have flexibility at all because of their life and work style, and because they take care of grandchildren or children during the evenings. And they were saying that they already have shifted everything they can to the hours of the day, and that's as much flexibility as they can have. But that also gives us an interesting insight here that even though household 5 had what is called low flexibility capital, the group as a whole managed pretty well and still managed to shift their activities as a group towards solar, which means that the group's total flexibility capital is still actually something good. So an energy community can support even members that have actually little flexibility by themselves individually. So we have a lot of interesting results that are also qualitative, that derived from a thematic analysis. I'm only going to give you here a very broad overview. We found, for instance, that there was indeed an increased need for within household coordination. As this person said here, I just like doing the project, booking in the time, and it's about putting your life into order. And I quite liked that bit of it. And that's exactly what irritated my wife a lot, I think, because she doesn't want to have to deal with that. And that actually shows that when you need to coordinate households and kind of book your things in advance, it brings also the need to coordinate within each household. And that had different levels of tensions with our participants, sometimes positive and sometimes negative. Like here it was kind of problematic, but in other cases it also brought discussions within the household of what does it mean to shift to solar and so on. We also saw that participants were using the bookings and were making bookings, but they didn't necessarily feel like they were part of a community, as in the way they had defined community by themselves. So a community in their definition was a group of people that talked or that met or that were supporting each other in times of need. But in this case, here, this person, for instance, says that I was a bit selfish about it. I tended to look what I wanted and whether other people have booked it rather than looking at the whole team. I kind of thought, oh, okay, this is blocked, I won't use it. But I suppose that's still working as a team. What this household 9 is actually realizing is that even though they were only looking at the bookings, they were still actually through that way working as a team. So the bookings actually offered this. The bookings helped them act as an energy community, even though they didn't feel as a community themselves, as it's defined. We also saw how this process brought empathy to your neighbors and how it made people feel like, for instance, families of 4 must be really going through it, unlike that person that was living by themselves. And that has a relation also to privacy, which we will discuss soon. So what did we learn about energy communities and our deployment of SolarClub? So as we discussed, we saw that bookings are a way to coordinate without necessarily provoking a community feeling. We saw that groups allow for further flexibility capital than what an individual can afford. And interestingly, something we didn't discuss yet, we also saw that the privacy preferences of the participants contradicted our initial design assumptions. So participants wanted less privacy. Participants wanted less privacy, and they wanted to know more information about the neighbors, as they claimed that the more they know, the more chances they are to be more empathic and be more flexible in case the other neighbor might be in need to take a slot, for instance, that they had booked already. So how does this work go from simulation to practice? So a lot of the current work on energy communities relates to automation. But we claim that even such individual deployments, like manual individual deployments, how we're doing here, are actually necessary to understand the nuances of collaboration, coordination, both within the household and across. And it also serves as ways to collect original data for informing further automated systems. Thank you. This was our work. Please do contact us for any further question, insight, comment, complaint, or collaboration opportunity. We're happy to hear from you.